Hi everyone and welcome to Master Calculator. In today's video, we're going to be going over exponent rules. Before we go over exponent rules, let's first define what an exponent is. An exponent shows how many times the base is multiplied by itself. So it's the small number on the top right. Now that we know this, we can start learning exponent rules, which basically help us when we're multiplying or dividing exponents. So let's jump right into it. On your screen, you can see the main exponent rules. Pause the video if you want to look closer, but we'll be going in detail through each one of these. Okay, let's first start with the most basic exponent rule, which is x to the power of a times x to the power of b is equal to x to the power of a plus b. Pretty simple. So let's look at a few examples. So 6 to the power of 3 times 6 to the power of 4. Well, we know we have to add a plus b. 3 plus 4. So 6 to the power of 3 plus 4, which is equal to 6 to the power of 7. Okay, let's look at this one. 7 to the power of 5 times 7 to the power of 3. Well, we have to do 7 to the power of a plus b. So 5 plus 3, which is equal to 7 to the power of 8. And finally, this one. 4 to the power of 15 times 4 to the power of 15. Well, that is equal to 4 to the power of 15 plus 15, which is equal to 4 to the power of 30. That's pretty simple. But just remember that you can see that in this expression, the x's, the bases are always the same. So that means you can multiply, let's just say 4 to the 5th times 5 to the 4th. You can't say that's like 4 to the 9th because 4 and 5 aren't the same. They have to be the same base. But other than that, that's pretty simple. You just have to add the top exponents. Okay, now let's move to the second rule. The second rule is that x to the power of a divided by x to the power of b is the same as x to the power of a minus b. So let's take a look at a few examples. 6 to the 6th divided by 6 to the power of 5 is equal to 6 to the power of 6 minus 5, which is equal to 6 to the power of 1. And we can just rewrite that as 6. So the answer to this question is just 6. Okay, second question. 15 to the power of 47 divided by 15 to the power of 3. So now x to the a divided by x to the b is equal to x to the a minus b. So 15 to the power of 47 minus 3. Subtract when you're dividing. You don't have to divide. That equals 15 to the power of 44. And this one also, like the other one, the bases have to be the same. So you can't do like 6 to the power of 6 divided by 5 to the power of 4. You cannot do 6 to the power of 2. So the bases need to be the same for this trick to work. Okay, let's look at the third exponent rule. X to the power of a to the power of b is equal to x to the power of a times b. This is also known as the power of a power rule. So let's take a look at these two examples. First one, 5 to the power of 2 to the power of 3. So basically what we have to do is 5, then the two exponents, multiply them together, 2 and 3. So 5 to the power of 2 times 3, which is the same as 5 to the power of 6. But how do we get this answer? Let's see why this works. So first, since we have parentheses, we have to do the 5 squared first. That's 25. And then that 25 is being cubed, so it's being multiplied 3 times by itself. 25 times 25 times 25 is equal to this expression. So let's make the 25s back into 5s. Each 25 is 5 times 5. So one 5 times 5, another 5 times 5, and another 5 times 5. So we started with this expression, 5 to the power of 2 to the power of 3. Then when we multiply that, we got 25 times 25 times 25. And we simplified even more to 5 times 5 times 5 times 5 times 5 times 5. 6 times. So that's why the answer is 5 to the power of 6. So let's look at this question. 6 to the power of 7 to the power of 11. So 6 to the power of 7 times 11. Just multiply the two exponents and we get 6 to the power of 77. It's really simple. But just remember, this trick only works when you have parentheses there. So for example, let's just say we had this same question, but it's 5 to the power of 2 to the power of 3 with no parentheses around the 5 squared. Well, what we have to do there is we have to do this part first. So instead of 5 to the power of 6, it becomes 5 to the power of 8. Because instead of doing 2 times 3, we do 2 to the power of 3, which is 8. Let's look at exponent rule number 4 next. This one's the simplest, but it's also the most confusing. So it states that any number to the power of 0 is equal to 1. Well, why is that? Any number to the power of 0, shouldn't it just be 0? Well, let's look at an example to see why this works. So let's look at the powers of 2. 2 to the third power, 2 squared, 2 to the first power, 2 to the 0th power. Okay, 2 cubed, that's 8. 2 squared is 4. 2 to the power of 1 is just 2. 2 to the power of 0, well, it's 1 according to this rule. And let's see why. 8 divided by 2 is 4. That's the pattern, divided by 2. So 4 divided by 2 is equal to 2. 2 divided by 2, well, that's equal to 1. So that's why it works. Any number to the power of 0 is equal to 1, because that's where it starts from. And then you keep multiplying by whatever that number is. In this case, it's 2. And when I say every number to the power of 0 is equal to 1, I mean literally every number. 6 to the power of 0 is equal to 1. This humongous number to the power of 0 is equal to 1. 5 times 4 to the power of 0, well, that's just the same as 20 to the power of 0. And you guessed it, it's 1. Well, what happens if there are negative exponents? This is where rule number 5 comes in. This states that any number to the power of negative a negative exponent, is equal to the same as 1 divided by that same base to the power of that exponent without the minus sign. So let's look at these two examples. So 5 to the power of negative 2. We go 1 over same base, it's 5. And then we just remove the negative sign and keep it the same exponent. 5 squared, which is equal to 1 over 25. Let's look at this next example. But in this next example, the negative exponent is in the denominator. It's in the bottom. So how do we do this? First, let's just look at this 2 to the power of negative 3 by itself. Without this 1 divided by 2 to the power of negative 3, without the 1, what would it be? It would just be 1 over 2 cubed. Like this negative sign won't be there. 1 divided by 2 cubed, same as before. But now we have to put the 1 divided by on top. We basically just wrote the 2 to the power of negative 3 as 1 over 2 cubed. But now what we have to do is let's rewrite it like this with the division sign. 1 divided by 1 to the power, and 2 cubed is just 8. So it's just 1 divided by 1/8. And if you remember how to divide fractions, we have to find the reciprocal of the second fraction. So flip the top and bottom, and we get 1, and we multiply them together. 1 times 8 over 1, which is equal to 8. This was a lot more steps and pretty much one of the most complicated rules, but after some practice, you'll understand it. All you have to do is write 1 and then divide that by the same base and then just remove the exponent. Remove the negative sign and just keep the same exponent. Just before we finish, let's go over this one question that combines a lot of the rules that we just went over. Take a moment to pause the video if you want to try it yourself. Okay, let's go. So first we have to start inside the parentheses. X squared times x cubed. So remember, when we multiply like numbers, we have to add the exponent. So that becomes x to the power of 5. 2 plus 3 is 5. To the power of 4. I'm just copying the rest of the equation. Divided by x to the power of 7. Okay, next step. We are still focusing on the numerator. X to the power of 5 to the power of 4. This is the power of a power rule. So now what we have to do is we have to multiply x to the power of 5 times 4, which is equal to x to the power of 20 divided by x to the power of 7. Okay, now we have to do one more step. X to the power of 20 divided by x to the power of 7. Remember, we're not supposed to divide the two numbers, but we're supposed to subtract them. So x to the power of 20 minus 7, which is equal to x to the power of 13. See, even this complicated looking problem is easy to solve if you know all the rules. See you next time.